Like many of the compounds we'll see throughout the semester, alcohols can be named either by the common, or sometimes I call that old-fashioned way, or the IUPAC, which is often referred to as systematic names. So you need to be familiar with both because both are going to be used. So let's look at some common names of alcohols. And the way that these are named is the alkane part of the alcohol is named as an alkyl substituent, and then alcohol is a separate word that's part of the overall name. So if we look at this first alcohol listed here, we see there are 2 carbons, so that's ethyl group, so ethyl alcohol. The next alcohol we have 3 carbons, 1, 2, 3, so that's propyl, so propyl alcohol. And the last example here we have 4 carbons, so butyl, butyl alcohol. Now the IUPAC nomenclature system names alcohols in a way that's very similar to naming alkanes. However, while alkanes always end in ane, alcohols will always end in -al. And then we always give the hydroxyl carbon the lowest possible number, and when we determine the longest chain, that hydroxyl group must be in that chain. So here's an example here of an alcohol, and no matter how we number our carbon chain that contains the hydroxyl, there are going to be 6 carbons. So I can start from this carbon up here, or I can look at the shaded part of this structure. There are 6 carbons, so that's going to be a hexanol. When we have a cycloalkane, the carbon that contains the hydroxyl group is always numbered as C1, but that C1 is never included in the name. Whereas in alkanes, we would always number where that hydroxyl group is. But in cycloalkane alcohols, that C1 is always where the hydroxyl group is, so we don't name it. So if we look at this particular alcohol, it would be called cyclopentanol. Right, after we identify the longest chain that has the hydroxyl group, we give the carbons index numbers so that the hydroxyl carbon has the lowest possible number. Now if you can give the carbon the same number no matter which direction you go, then go in the direction that gives the branches the lowest possible number. Okay, and then for an alcohol and a cycloalkane, number the substituents so that they're the smallest possible number, remembering that the 1 is always where the hydroxyl is. So then the last step after we number all the carbons is to name the alcohol. So it's going to end in -al, will indicate where that hydroxyl group is by an index number, and then if there are any branches, we list them and their index numbers alphabetically. So let's look at some examples here. In the top left-hand corner, we have 5-methyl-3-hexanol. So the longest carbon chain contains 6, so it's a hexanol. The smallest number we can give the carbon with the hydroxyl is 3, and so that gives the methyl a 5 position. If we look to the right of it, we see 1-butanol. Remember, we've got to give this hydroxyl group the smallest possible number, so this would not be 4-butanol, it would be 1-butanol. And down in the lower left-hand corner, we have a substituted alcohol, and we're going to give the carbon that has the hydroxyl the smallest possible number. And the longest carbon chain that contains that hydroxyl has 7 carbons, so it's a 2-heptanol. And then we order the substituents in alphabetical order. So this 4-chloral comes before the 6-methyl, not because 4 is lower than 6, because the chloro comes C in chloro comes before M in methyl alphabetically. And then last but not least, in the lower right-hand corner, we have 2-methyl-cyclohexanol. And just notice that we don't write out that the carbon is a 1, that the hydroxyl group is on.